Hi everyone. Today we're going to study infinite series. Given a sequence of numbers a sub 1 plus a sub 2 plus a sub 3 plus a sub 4 plus up to a sub n is called an infinite series. The notation is a sub n is enclosed in a parenthesis. The number a sub n is the nth term of the series. Now let's go to the partial sums S sub n of infinite series. The partial sum of the series forms a sequence of real numbers, each defined as a finite sum. Example, S sub 1. This is equal to a sub 1. For S sub 2, the elements are a sub 1 plus a sub 2. S sub 3 equals a sub 1 plus a sub 2 plus a sub 3. Then we reach S sub n. This is equal to a sub 1 plus a sub 2 plus a sub 3 plus up to a sub n. If the sequence of partial sums has a limit s as n approaches infinity, we say that the series converges to the sum s, and we write a sub 1 plus a sub 2 plus a sub 3 plus and so on plus a sub n plus and so on. We write this in sigma notation as summation from k equals 1 up to infinity of a sub k. And this is equal to that sum s. Otherwise, we say that the series diverges. In other words, an infinite series a sub 1 plus a sub 2 plus a sub 3 plus up to a sub n plus and so on is said to be convergent if the limit of the partial sum, such as the limit as n approaches infinity, s sub n. This is equal to the limit as n approaches infinity of the summation from k equals 1 up to infinity a sub k exists and is equal to a finite value s. Otherwise, it is said to be divergent. Examples of infinite series are power series and geometric series. Today, we're going to study geometric series. In science and engineering, we often write functions as infinite polynomials. For example, we have 1 plus x squared plus x cubed plus up to plus x raised to n plus and so on. We can write this in sigma notation like summation from n equals 0 up to infinity of the function x raised to n. Or we can write like this, summation from n equals 1 up to infinity of the function x raised to n minus 1. When the absolute value of x is less than 1, we can write the sum of these infinite polynomials, and it will be 1 over 1 minus x. For any value of x, we evaluate the polynomial as an infinite sum of constants. A sum we call an infinite series. Let's go to geometric series. A geometric series is the sum of an infinite number of terms that have a constant ratio between successive terms. We can write a plus a times r plus a times r squared plus a times r cubed plus and so on. The r here is the common ratio, and a, we can see that it is the first term. In sigma notation, we write summation from n equals 0 up to infinity of the function a multiplied by r raised to n. Take note that geometric series converges if the absolute value of r is less than 1 and diverges if the absolute value of r is greater than or equal to 1. Let's have example. Identify the first term and common ratio of the following geometric series. Also, determine if it converges or diverges. Let's start with problem A. Summation of n equals 0 up to infinity. The function is 5 multiplied by the quantity 1/2 is raised to n. Here, the first term, which is a, is equal to the number 5, while the common ratio, or r, is equal to 1/2. To test for convergent or divergent, we say that the absolute value of r is equal to the absolute value of 1/2. When we simplify, this is equal to 1/2, which is less than 1. Therefore, this series converges. Problem B, summation from n equals 1 up to infinity. The function is 2 multiplied by the quantity negative 2/3, and this is raised to n minus 1. The first term is a, and that is equal to 2. And the common ratio r is equal to negative 2/3. To test for convergent or divergent, we say that the absolute value of r is equal to the absolute value of negative 2/3. Simplifying this, we have positive 2/3. And this 2/3 is less than 1. So we say that the series converges. Problem C. Summation from n equals 1 up to infinity of the function 3 times the quantity 7 is raised to n minus 1. The first term a is equal to 3, and the common ratio r equals 7. Testing for convergent or divergent, we say that absolute value of r equals the absolute value of 7. Therefore, this is equal to 7. And we can see that 7 is more than 1. Therefore, this series diverges. Today, we're going to study sum of geometric series. Given a geometric series, summation from n equals 0 up to infinity of the function a times r raised to n. If the absolute value of r, or the common ratio, is less than 1, then the series converges, and the summation from n equals 0 up to infinity of the function a times r raised to n equals a over 1 minus r. Remember, a is the first term and r is the common ratio. Let us see this example. Determine whether the following geometric series are convergent or divergent. If convergent, find the sum. We have two sample problems here. Let's begin with problem A. Summation from n equals 1 up to infinity of the function 5 times the quantity 1/2 is raised to n minus 1. Collecting the values, a equals 5 and r is 1/2. The absolute value of r, we can write absolute value of 1/2. And the value here is equal to positive 1/2. We can see that this is less than 1. So we say that the series is convergent. Since this is convergent, we can use the formula for the sum, a over 1 minus r. Substituting the values, we have 5 over 1 minus 1/2. Simplifying the denominator, it will be 1/2. So 5 over 1/2 is equal to 10. This is the final answer. Now, problem B. Collecting the values, a equals 2 and r equals negative 1/3. The absolute value of r is equal to absolute value of negative 1/3. And this is equal to positive 1/3. And 1/3 is less than 1. So we say that the series is convergent. We can use the formula for the sum. Let us now substitute the values. The a becomes 2 all over 1 minus the r is negative 1/3. Negative and negative becomes positive. So 1 plus 1/3 becomes 4/3. And this complex fraction, we can show that 2 multiplied by 3 over 4. And this will be simplified into 3/2. This is the final answer. Today, we're going to study power series and interval of convergence. A power series about x equals a is of the form summation from n equals 0 up to infinity of a sub n multiplied by the quantity x minus a, and this is raised to power n, where a is the center of the series. In many situations, a is equal to 0. So we can write again a power series about x equals 0 is of the form summation from n equals 0 up to infinity of a sub n times x raised to n. Further, the power series is a series in the form summation from n equals 0 up to infinity of a sub n times x raised to n, where a sub n and x raised to n are numbers. The a sub n, where the subscript n equals 0, 1, 2, 3, are coefficients of the series. Note that a power series is a polynomial of infinite degree. Let's go to interval of convergence of power series. Let the power series summation from n equals 0 up to infinity of a sub n times x raised to power n have radius of convergence capital R that is greater than 0. The convergence of the series will depend upon the values of x that we put in the series. Let us see example 1. Find the interval of convergence of this power series. This is a power series with center at 3. Note that this is also a geometric series with common ratio r, which is equal to negative 1/2 times the quantity x minus 3. We know that a geometric series converge when the absolute value of r is less than 1. Thus, we're going to copy this value of r in here, and then let us represent this in terms of double inequality. And it will be like this. So the common ratio is between negative 1 and positive 1. Let us simplify the double inequality. Let us multiply by 2. The left side becomes negative 2, and the fraction here is deleted, while the right side becomes 2. Simplifying the middle value, we have now negative x plus 3. Let us isolate the negative x. We want this positive 3 to be deleted. So the left side becomes negative 2 minus 3. The middle term becomes negative x plus 3 minus 3, while the right side becomes 2 minus 3. Simplifying this, we have now negative 5 is less than negative x is less than negative 1. We want this negative x to be positive. Let us multiply by negative 1. We know the rule of inequality that when we multiply by a negative value, the direction of inequality changes. So we have now 5 is more than x and is more than 1. We can rewrite this double inequality into like this. So x is between 1 and 5. This is our answer. It means this series is convergent when x is between 1 and 5. Example 2. For what values of x does the series summation from n equals 0 up to infinity of 2 raised to n times x raised to n converge? This is a power series with center at 0. Note that this is also a geometric series that can be rewritten as summation from n equals 0 up to infinity of the quantity 2x that is raised to power n. Then, we can collect the common ratio r that is equal to 2x. The series is convergent when the absolute value of r is less than 1. Let us substitute the value of 2x in here. Let us represent this inequality into double inequality, and it will be like this, that 2x is between negative 1 and positive 1. Let us divide this by 2 to make x isolated in the middle. The left side becomes negative 1/2, the middle term becomes x, and the right side term is positive 1/2. This is now the interval of convergence.